My name is Sundaresh Ramanathan. I'm the Vice President of Engineering at Kinney Group. Kinney Group, we are primarily a Splunk partner. So we do a lot of consulting work related to Splunk. David, he's a Splunk sales engineer. He's here to help me with the demo and the presentation. Before I get started about Splunk, by show of hands, how many people in this room are familiar with Splunk, are either using Splunk, or I've seen Splunk before, or heard of Splunk? Good. About half the crowd. The rest, I'm assuming you're not familiar with Splunk. So what I'll do is I'll take about 10 minutes, give you a quick introduction on Splunk, and then hand it over to David. Today's topic is primarily machine learning in Splunk. So I'll introduce Splunk, I'll introduce machine learning, and David had some really cool demo of machine learning, using machine learning in Splunk. So Splunk, it's not a tool, it's a platform. So what that means is Splunk is an aggregator of any kind of time series machine generated data. The primary difference between a tool and a platform is that a tool is a singular focus, so you get a tool to do one thing or a handful of things, whereas with a platform, you can customize or tailor the platform to solve whatever problems you may have, right? And Splunk is the platform for data analytics. So any type of time series machine generated data can be ingested into Splunk with little to no effort, right? So the data can be, specific to the application domain, can be specific to IT ops, can be in the security space. So any kind of data can be ingested into Splunk. And once the data comes into Splunk, you can use it time and time again for any and all kinds of use cases, right? So if you have a large data center or a large IT infrastructure and you want to monitor what's happening with your IT infrastructure, you can ingest all the data, right? You can get your storage data, your network logs, machine server information, event logs, security logs, all of it into the same Splunk instance. And then you can correlate and build all kinds of searches and look for cool nuggets within the data. So unlike specialized tools, which allows you to ingest, say, only network logs or only server logs, with Splunk you can ingest any and all kinds of logs. Once you get the logs in, Splunk has a really robust dashboarding or visualization capabilities, right? It comes built in with all kinds of visualization controls. So once the data is in, you can aggregate and correlate data across different data sources, and you can create different views. So for example, if you want to create an executive view to give you a quick health for the senior executives, right? A quick snapshot of the health of your data center or the health of your infrastructure for your senior executives, you can do that. And then you can have a drill down or a more detailed view for the operations team. So let's say you have a network operations center that's looking at TV monitors. They can have a specific view built just for them. The other cool thing about Splunk is because it's interactive, it allows you to drill down to the root cause much faster, right? So let's say you see a spike in your data at some point, or you see an error, or you see an anomaly. The visualization is highly interactive, and it enables you to drill down and get to the root cause, find the needle in the haystack, if you will, right? So again here, so let's say you're doing application delivery and you want to look at your DevOps pipeline, right? You want to look at your CI/CD pipeline. You can do that. Or if you want to look at the health of your systems, health of your servers, you can, it's the same platform, it's the same data sources. The only difference is the correlation and the view that you can build and you can generate to analyze the data. Splunk also has a very robust machine learning capabilities. Machine learning has been around in Splunk since version 6.5. And machine learning in Splunk comes in 3 different forms. The easiest and the most widely used form of machine learning is in its premium apps. Premium apps are apps that are purpose-built for a specific problem or a business problem, right? So for example, Splunk has a premium app called Enterprise Security, which is purpose-built same using the logs that is ingested into Splunk. The Enterprise Security has machine learning capabilities to detect anomalies, automatically detect anomalies in a log, and alert you of any threat or anomalies that it detects. Similarly, Splunk has a premium app called IT Service Intelligence, which is purpose-built for IT operations and infrastructure monitoring. The cool thing about IT Service Intelligence is, again, it uses machine learning, and it's more of a proactive monitoring tool as opposed to reactive monitoring tool. And what I mean by that is, most tools that that are found today in the IT ops space is analogous to looking in a rearview mirror in a car, right? So when a problem occurs, the tool will notify you, and then you can go drill down and find out what the root cause of the problem is. With IT Service Intelligence, with the help of machine learning and adaptive thresholding, IT Service Intelligence is able to predict a problem, so you're able to determine and prevent problems as opposed to just doing a root cause analysis. So that's the most common use of machine learning within Splunk. But machine learning algorithms are also available in just the plain vanilla Splunk platform, right? So if you're familiar with machine learning algorithms, and you can use, and if you're familiar with the Splunk search language, then you can use the machine learning in your everyday searches. There are custom commands that are created that will execute, I think there are about 25, 30 different algorithms that are built into the app, and those are extensible. You can add more algorithms if you choose. And then finally, Splunk also has what is known as a machine learning toolkit. The toolkit is designed to help Splunk admins and Splunk users adopt machine learning without being a data scientist, right? So they try to simplify the whole notion of machine learning and data science by presenting a simplified user interface that walks you through creating a learning model and analyzing data and applying the learning model to data as it comes in. The machine learning toolkit has access to the same algorithms that are available in the Splunk platform, the core platform, and it's also the same algorithms that are used for the most part by the premium apps like Enterprise Security or IT Service Intelligence. With that, David, I'll hand over to you. David will walk you through the machine learning toolkit and show you some cool demos on how that can be applied.
Thanks, Sundaresh. All right. Okay, so first what I want to talk about is what the machine learning toolkit is. So it is a layer over top of the Python machine learning libraries that a lot of folks may already know. SciPy, scikit-learn, NumPy, those types of things. And it's built into a set of experiments and assistance to make those algorithms more accessible to both folks who understand the use of algorithms and then maybe also folks that may not understand those as well. And then there's also an API around the machine learning toolkit that lets folks that understand the Python ecosystem and the Python machine learning be able to extend the machine learning toolkit. So the toolkit implements A number of algorithms, it's 80 plus, that increases with each version. So what they do is all of the algorithms and so forth that are in scikit-learn and so forth, they will take those and then implement them within the toolkit so that there's a visual experience around those algorithms to be able to, and then you feed those algorithms with data that you query from Splunk. So those algorithms can operate on any data out of Splunk. So basically it makes it very accessible, and then Splunk allows you to manipulate your data and so forth. It's a pipeline type language versus a SQL set based language, and so you're able to operate on your data on a pipeline as you pass that along. So this I talked a little bit about. Basically, the Python scientific computing libraries are implemented in Splunk, and then the machine learning toolkit rides over top of that. And then Splunk implements the fit, apply, and score commands for each of your methods. So you have things like, fit linear regression, right? Fit random forest, those types of things. And then you can score and get your error metrics, things like R squared, root mean squared error, those types of things that you can get from running your model. And then Splunk gives you the ability to operationalize that model on new data coming in. That's where the huge value of Splunk really lies, in the ability to operationalize that process. So Sundaresh touched on this just a little bit, but the machine learning toolkit is really kind of targeted at that person with some data science knowledge, some knowledge in whatever domain expertise from your data, and then a little bit of Splunk expertise. And then we use that machine learning toolkit to implement machine learning for other folks for known use cases that Sundaresh talked about, like within security and ITSI and so forth. The machine learning toolkit is really meant for programmer/citizen data scientists to be able to implement machine learning in custom type of use cases on their data. And so I talked a little bit about this. Basically, it gives you the ability to explore and then fit your algorithms, test, and then apply. And then the dashboarding and so forth gives you the ability to take the things that you've done within the machine learning toolkit and then expose that information to other users to be able to consume the results of those models. All right, so let me just... So when you first open this machine learning toolkit, what you get is a showcase that this is basically test data that allow you to use the different models within Python that have been implemented in the machine learning toolkit. So you've got regression, predict numeric fields, categorical, you've got time series, outlier detection, all the different types of models that you can use in different types of use cases. And there's examples, a lot of these are from the IT type of use case, right? So we can look at things like predicting hard drive failure, and what that will do is it pulls some test data and it will automatically fit the model, which is what's going on right now. It will go out, it grabs this data, and then it runs the fit command to try to predict disk failure. And so what it does is it compares, it's using a training data set. You can set, how you split for test and train. There's different commands to do cross-validation, all of those types of things. And this gives you a visual way to interact with the model using test data. And you can see it, gives you some of your accuracy and fit and so forth. The other piece that I can do with this is I can run different experiments, right? So this is using the same type of assistant interface, but maybe with your own data. So this is a data set that's actually from UCI. If you guys are familiar with the machine learning data sets out there at the University of California, Irvine. This actually comes from that. And here you'll see Splunk actually has the ability to interface with all types of data sources. We're known for logs, but we can actually act as a REST endpoint and take JSON data. We can interface with databases. This command here is actually reaching out and grabbing data from a SQL database. This data is actually not even in Splunk. And so you can bridge the gap between all kinds of different data sources in Splunk, right? So in this case, what I'm doing is I'm doing a query. I'm bringing this data in, and then I want to run an experiment on this. So I'm predicting concrete strength, using everything but that for the prediction, and then it will run. It's in this particular case, it's using random forest regressor. You can choose the different algorithms that Splunk has for regression, and so you can try the different ones to see which works out best. And then you can see it gives us some information about our data. It tells us the distribution, how well the data is grouped on a scatter plot, predicted versus actual. And then this is something that shows you, your importance of each of the variables and so forth. And so this just gives you an interface to easily kind of explore your data and so forth. And then what you would do when you went to operationalize this data. So if we look at the show SPL, what this is actually doing, I don't know how well you can see that, but what this is doing is it does the query, and then it's applying the model and then looking at the different residuals. So right here where you're applying this model, that's what you would do for new data. So say you're wanting to predict new data that's coming in, you would run apply, and you wouldn't provide the training, right, the outcome variable, and then that would be driven to drive a dashboard or something along those lines for your prediction. And so if you think about the way that the machine learning works in Splunk, it's the same Python libraries that are used. Where the real value comes in is the ability to give you access to all of that within a data platform so that you can easily operationalize those models. That's where the huge value comes in, along with the ability to customize and so forth. So I want to jump just a second into another topic. So this data set, this is the Splunk query language. And so this is a time series data set. It's actually a bunch of financial information. But what you'll see here is that this data is actually at all kinds of different intervals. I've got daily data here, I've got weekly data, I've got monthly data. But if you look at the commands where it says reverse, fill down, so forth, this is a really common task for data scientists. They're cleaning data and filling things in. And so in order to analyze this time series data set, what I have to do is actually fill in previous values with in the next values so that I can do that calculation. This does that very easily. Also things like, you know, if you're familiar with Python, creating dummy variables and those kinds of things, there's commands within the Splunk language. There's actually a command in the Splunk language that's a direct accesses get dummies in Python to be able to create dummy variables for categorical values and those kinds of things. And so that's a big value that comes in with Splunk. So the other thing that I wanted to talk about with Splunk was the ability to create custom algorithms. So I want to pop this up. So within Splunk, basically, the machine learning toolkit also has an extensibility API. So if you're familiar with developing Python and you're familiar with using all of those, you know, scikit-learn, numpy, scipy, all of those algorithms, basically what you do is you create a Python class and you inherit from our base algo class, and then this gives you the ability to create all of your own custom Pythons. So if you look at like this right here, feature variables, target variables, these are things that get passed in the data stream to your custom algorithm so that you can operate on that. What I did here is this is actually a custom algorithm that's an example from our documentation, and also it happened to fit perfectly for what I needed. So this uses pandas, and it uses the correlation method on pandas. You can see right here. So requested columns, the data inside of Splunk that gets passed to these algorithms, it actually gets passed in a pandas data frame. It's transferred and passed in a pandas data frame so that you can operate on that. And then what happens is I can implement those custom algorithms, and this is the end result. So this is something that I'm working on. If anybody's ever heard of Markowitz's modern portfolio theory, I'm trying to implement that in Splunk, and I'm part way. Basically, what it does is you take a number of stocks, the return over a period of time, and then you take the covariance and correlation, and you can figure out the theoretical risk and return of that portfolio. So that's kind of what I've done here. So if you look at the custom search on this, what it's doing is it's taking data from Splunk, and I'm using Splunk commands to calculate the daily return by subtracting the previous day from the current day and so forth. And then I'm using the machine learning toolkit to also do some weighting of the stocks and so forth. And then I'm fitting that correlation matrix, and when you look at this is the same data, and then it just fits into this dashboard from Splunk, color codes everything based on correlation, negative or positive, and so forth. And that's kind of an example of how you might implement your own stuff within Splunk. And then I will make sure that this information gets out to you, but this right here, so really, you know, just to leave you, the machine learning toolkit's kind of targeted at data scientists and developers and so forth, but it really helps those folks implement the things they're doing and make them accessible to the rest of the business and so forth. That's where the value of machine learning in Splunk really comes in. And with that, I'll make sure that these get out to you guys, but here's a bunch of resources that if you want to learn more, there's a GitHub repository that has examples of custom algorithms. There's a ton of stuff from our past conferences that are out there online. That's great learning resources, and that's all I have.
Awesome, thanks, David. Does anybody have any questions for David before? Cool, Danny.
Hi, David. Thank you. I'm just wondering how you mentioned of the Splunk command. How easy is that compared to the Python command? Like,
The Splunk language?
yeah, the same. Yeah, the language.
Personally, if it's new commands and things. It's new commands and things to use, but and there's a little bit of a learning curve there. But if you're familiar with SQL and you're familiar with pipelining type of languages and so forth, Bash, it's really not hard to pick up because it's, once you start to use it, it gets to be fairly intuitive. And while the language is really huge, you can accomplish, it's like 80% of what you want to do with 20% of the language kind of a thing, right? So. Sure.
Great question. Any other questions? Cool, hey Jay. Here, let me give you the mic.
So I know Splunk is, traditionally been used a lot for log stuff, and so time series makes a lot of sense. A lot of the machine learning libraries in Python aren't necessarily, especially scikit-learn is not really designed for that. So what sort of libraries are you guys implementing for some of that time series analysis? And do you do any Bayesian stuff with it? Do you do any neural net type stuff, which is a lot more sophisticated to do for time series than it is for a lot of the machine learning applications?
Yep, absolutely. So yeah, that's so I use a kind of a genetic algorithm for some time series stuff on the side of my own. So the machine learning toolkit in the newest versions, and this is something that you really have to go to our machine learning folks to implement today, but it's coming more mainstream. So we have a bridge from the machine learning toolkit to TensorFlow containers. So you can use TensorFlow within Splunk and feed the data. So that's one thing. The other piece, the machine learning toolkit itself really has a REMA, which, right, limited usage depending on what you're doing, right? There's also I never know if I'm pronouncing this right, but Kalman filter, right, for doing time series, and that's actually built into the base language in Splunk, right? So, and it works okay for as long as it's, it's a trending or it's a seasonal data set, and it's for a lot of IT type predictions that's there. But what you're talking about, the bridge to TensorFlow, we also have a bridge to Spark ML lib. There's some stuff going on there too.
Do you guys have FB Profit in there at all?
Not that I know of. That's not something that rings a bell for me.
So it's a Bayesian base.
Okay. We'll talk in a minute about that.
Cool.
Okay.
Cool. Danny, you're back.
Oh, sure. Oh, just a follow-up question. So you mentioned on one of the slides that you can kind of choose the algorithm, like random forest or Bayesian, whatever. Can you choose like I don't know if you're familiar with the hyperparameters, like the learning rate, the momentum, the optimizer, yeah.
So yes, you're starting to get over my head a little bit, right? Right. I'm very much learning in this, but basically, the algorithms that support some of those options, those options are implemented. So in the drop downs, sorry, I need my glasses. So if you see right here, oh, right. So some of the, depending on the algorithm, the options for those algorithms that have been implemented by the machine learning toolkit will show up there to be able to add those.
I think we have time for one more quick one, if anyone has one. Nope. Oh, okay. AJ, last one. I'll come back to you.
So you had a repo up there. Is the toolkit open sourced, or what's in that repo, so to speak?
So that repo are algorithms that have been added to the toolkit by the community. Okay. What I will say is you can play with the tool, you can do a lot with the toolkit as an individual and experiment and see if it will work for you by doing two things. You can go to dev.splunk.com and you can get a developer license that will give you 10 gig daily ingest for a single machine that you can, and the toolkit itself is free. You add on top of Splunk, so you can do a lot and see if it's a right fit for what you want to do without spending anything.